Hello friends, I am Dr. Ashutosh Upadhyay from Department of Physics. Today I am going to talk about particle confined in a one-dimensional infinite potential well. To solve this problem, we need Schrödinger wave equation. So the Schrödinger wave equation can be written as a one-dimensional time-independent Schrödinger wave equation can be written as this, where psi x is a wave function, E is the energy, V is a potential, and m is a mass of the particle, any system, where h cross can be written as a h over 2 pi. This h is called reduced Planck's constant. This equation can also be written as this form, where this h bar square is replaced with h, and the three-dimensional equation can be written as this way, which is we will not consider three-dimensional because in our problem itself it is written one-dimensional infinite potential well. From using the Schrödinger wave equation, we can estimate the energy, the potential of the system, the wave function of the system. That is why we need the Schrödinger wave equation. So coming to the today's problem, which is we have to calculate the what kind of energy a particle can be, what will be the wave function of the particle which is confined in one-dimensional infinite potential well. To make this problem, let us assume that if we have any metal rod in which there are many electrons are there. So how this electrons behaves in a metal? This electron can be freely moving in a metal if we apply some potential, but this electron cannot move out of the metal. Why it is so? We will try to understand what will be the energy of this particle if we will consider only one electron, which that we can make in our problem also, and one particle in a infinite potential well. The height of the potential well is infinite and the width of the well is L, x equal to 0 to x equal to L. So this particle is free to move inside this well. To and fro motion will be there with these two walls. It will go that side and hit the wall and come back to this side and hit the wall, and it can move in one dimensional only, the positive x and the negative x. I can ask you, what is the probability of finding this particle outside the box? The probability will be 0 outside because it cannot cross over the potential, because the potential is infinite. The particle cannot acquire infinite energy to cross there, which is not relevant. So the particle can never be outside of the box. So particle can move inside. If particle is moving from de Broglie hypothesis, we can say there will be also a wave associated with this moving particle. If there is a wave associated with the moving particle, then we can write a wave function also, which is we are writing psi of x inside the potential well. But outside the potential, outside this infinite well, the particle can never be there. So there will be never any wave function also. Psi x will be 0 out of the box. This side and also this side also. Psi x will be 0. This is 0. And the potential inside the well is 0. Outside the well is infinite. This side also it is infinite potential. This side also it is infinite potential. So we can write the boundary condition for this V of x will be 0 for x is greater than 0 and less than L, and the second boundary condition can be written as V will be infinite for x greater or equal to less than L and x can be less than or this should be less than or equal to x. So, by using these two boundary conditions, we can solve the Schrodinger wave equation. So, these are the boundary condition. First one is V is 0, V is infinite for these conditions. Then we can write the Schrodinger wave equation for this problem. This is the general Schrodinger wave equation in one dimensional, which we can write like this. Now, we can replace our potential with these two, V is 0 or V is infinite. When V is infinite, which is outside the box, V is infinite. So, if V is infinite, it means there is a no particle. If there is a no particle, means there is a no wave, then we cannot write the wave function psi of x. So, for this condition, the wave function can be, we cannot write any wave function for this condition. So, we have to solve only for Vx is equal to 0. So, we can write this same Schrodinger equation as a d2 of psi of x over dx square plus 2m over h cross square within bracket E psi of x is equal to 0, because V of x is 0 from this. Now, we have to solve this Schrodinger wave equation. d2 psi of x over dx square plus 2m over h cross E of psi of x is equal to 0. This again we can rewrite the same equation as a dx square plus, this is equal to minus of 2m E h cross square psi of x. If we see this equation, this is, we can assume that this as a new constant, all are constant in this, the 2 is constant, the mass of is a constant, energy, these are some constant value. So, we can replace with some another constant, that is called k square, which is equal to 2m E by h cross square. So, this equation can be rewrite again d2 psi of x over dx square is equal to minus k square psi of x. This is a second order differential equation. We can write direct the solution of this equation, because if we see this equation, this is as same as a simple harmonic motion. There also, if we have seen that, if you remember that equation, like F can be written as minus of kx, this force can be written as a mass multiplied by d2x over dx square is equal to minus of kx. So, this I can write d2x over dx square is equal to minus k by m of x. This k by m we can write minus of omega square x. So, this is the general simple harmonic motion. The solution of this, if we check, it was there, x is equal to a sine of omega x plus b of cos omega x. Similarly, we can write the general solution of this second order differential equation, which is psi of x can be written as a sine of kx plus b cos of kx, where a and b are the constant. By solving this equation, we will try to find the value of a and b. We have done, we have done the psi of x is equal to a sin of kx plus b cos of kx. Now we have to find out the value of a and b by using some potential well. V is a infinite here, V is infinite at x equal to 0 and at x is equal to L, and the particle is inside this well is moving. So we can check the boundary condition for x equal to 0. At x equal to 0, the potential is infinite. If the potential is infinite, means the particle cannot be there at that point. If there is no particle on x equal to 0, means there will be no wave there. If there is a no wave, it means psi of x will be 0. The function of the wave also will not be there. So we can write psi of x is equal to a times sine of k multiplied by 0 plus b cos k times 0. We are replacing x by 0. So this also is equal to 0 because the wave function is 0. So we can write this a times sine of 0 means k times 0 means 0, sine of 0 is 0 plus b times cos of 0, cos of 0 is 1. So we can see here the b is equal to 0. Now our wave function is reduced to a times sine of kx because the b term is 0. It was here previously b dot cos of kx. Since b is 0, so this total term will become 0. Okay. So we will check what is the value of a. Can a be also 0? No, because if a is also 0, it means there is a no wave. All the things will become 0. It means there is a no wave exist. So a can never be 0. A can never be 0. We have to find the value of a somehow. Let's check what will be the value of a. For that, we will check for boundary condition of x is equal to L. Now at x equal to L also the potential is infinite. So it means the wave function will be also 0 at this point x equal to L. The wave function will be 0 because the potential is infinite. So we can write the wave function as a psi of x is equal to a times sine k times x. As place of x we are replacing with L, and this psi x is 0. So this will become 0 is equal to a times sine k L, or we can write this equation as a sine k L is equal to 0. Since we understand a can never be 0, it means this KL may have 0 value, some value for which we can get the sign of that KL is 0. So for which values of KL the sign will be 0? Yes. So KL can take the values of, KL will take the value of pi, 2 pi, 3 pi, like this. There are other values of pi. So it can take only positive pi values, integer of pi values. So I can write as a KL is equal to of n pi, where n is a positive integer n is a positive integer. It may be 1, 2, 3. It can never be 1.1 or 1.2. It is only the integer 1, 2, 3. Okay. So, we got the value of k from here. L is equal to n pi. It means k is equal to n pi by L. N pi by L. If you see here, we have got the b is equal to 0. It means psi of x is equal to a sine k. So, k is equal to n pi by L. And also we have somewhere we have assumed that k square m e over h cross square. From these two equations we can find out the value of energy. It will become n square pi square h square over 2 m L square. These 2 will be multiplied by, and this 2m will come to the denominator of this side. So, it can be written as like this. So, we have find the energy value. This is also called the eigenvalue of the system. E is also called eigenvalues. And we find the wave function also, psi of x is equal to a sine of k x, where this k can be also written as a sine n pi x over L. Now, our job is to find out the value of A. What is the value of A? For this also energy we have written here, n square pi square h cross square by 2 ml square. If we replace the h bar square, it will become n square h square over 8 ml square, because this is the reduced Planck's constant. We can replace this with the h by 2 pi. So, this equation and this equation are same, only the difference is the reduced Planck's constant or Planck's constant. So, from here we can conclude that the energy is quantized. We find that energy is quantized. Energy is a form of 1 n square pi square. N is a quantum number, so it can be either 1 of h square pi square over 2 ml square, or 4 of different En value we can write also. En is equal to n square pi square h cross square over 2 ml square. So, n can be 1, 2, 3 or so on. So, let us see if it is n is equal to 1. So, E1 will become E1 1 square pi square h cross square over 2 ml square. So, this is 1 square means 1. So, E2 will become 2 square pi square h cross square over 2 ml square. So, 2 square is a 4. This also can be written as a 4 times of E1. If you check this, the 4 times of E1 is a E2. What will be E3? Can you guess? For E3, E3 will be 9 times of E1, because 3 square 9, and the same thing will come again. So, it will become 9 times of E1. So, we can see here the energy is a quantized. Energy is a not continuous. It has some discrete values, E1, E2, E3, different energy labels are there. It is not a continuous thing. So, therefore, energy spectrum is discrete, which is in contrast of classical physics. Means if we have a wall of two sides and a ball of cricket ball or any marble is moving in this, which is a classical body, then we can say what will be the energy of this ball? This ball can have any energy. Why? Because of different energy, its motion will be there. If it has high energy, it will be fast moving. It has low energy, it may be slow moving in these two walls. So it can have any value of energy if it is a classical ball, but if it is a microscopic particle, then it can have only discrete value of energy, which is E1, E2 or E3. It can never be a continuous. Still we have not done with our A value, because we have written that the wave function is a times sine of n pi x by L. Now we have to find out the value of A. So from the equation, by squaring of we'll try to get the probability of this from minus infinity to infinity. Psi of x, psi star of x dx will be 1 in the limit of 0 to L. So we can reduce this from 0 to L. Psi of x is a times sine n pi x by L multiplied by again psi star, which is complex conjugate of the same wave function, which is the same sine of n pi x over L, and dx is equal to 1. So we can see here A and A will become A square 0 to L, and sine of this will become sine square n pi x over L, dx is equal to 1. Now we have to integrate this to find out the value of A. What we can do here, we can write the sine of square is like this. Sine square can be written as 1 minus cos of 2x divided by 2. Then we can replace this sine of x with this formula. So this will become a square 0 to L sine we cannot, we have to replace with the 1 minus cos of 2 times n pi x over L divided by 2 d of x is equal to 1. Now we have to integrate this. Okay, we need to solve this A value. This can be written as a 2 also. So we will solve this. A square over 2 within bracket integration 0 to L, 1 into dx will become dx minus 0 to L cos 2n pi x over L dx is equal to 1. So if we integrate dx, it will become x 0 to L, and prior to that we have to write this a square by 2 minus cos, we can write sine of 2n pi x over L divided by 2n pi by L, and the limit is again 0 to L is equal to 1. So if we check here, it will become L, and 0 means 0, though this will become x, And if we see here, if we replace the x with L, this L cancel, 2n pi, sine of 2n pi is 0. So this term will become 0 if we will keep the L. If we keep the x value is 0, then also sine of 0 will 0. This term always give us 0 value. So this is minus 0 is equal to 1, and out of this is there. So we can find from here that x will become a square by 2 into x will 1. So this implies that a is equal to 2 over, sorry, this is L also, we have to write L not x, 2 by L under root this. So a value is coming 2 over L. If we check here, we have solved this systematic to find out the value of a. A will become 2 by L. So if a is 2 by L, then wave function will become psi of x can be under root 2 by L sine of n pi x by L. How we started with psi of x? Psi of x was there a times sine of kx plus b times cos of kx, which is now replaced because a value is root 2 by L. So this is becoming, because b is 0, this term is always 0. So only we have to replace this, and k value is n pi by L. So psi of x will become like this. So different n value, n is 1, 2, 3, different value of n, we will get different value of wave functions. So as we have the energy also different En, similarly we have the wave function also different E1, E2, E3 energies are there, psi 1, psi 2, psi 3. The wave function also we have different wave function. En, which is E1, E2, E3 or ... and similarly the wave function also can be psi 1, psi 2, psi 3 or so. The particle can never be a zero energy, E0 is not possible and psi of 0 is not possible because that because psi can never be a 0 point energy because we have only the positive integer value of quantum number. So n can be either 1, 2, 3, 4 or so. N can never be a 0. If n is 0 means there is a no particle. So therefore we have the ground state energy, this is called E1. This is the lowest energy, and this is also lowest wave function. Different energy values E1, E2, E3. The particle cannot have zero energy even in the lowest state. It has always some value of energy. Similarly, the wave function can be written as a psi 1, psi 2, psi 3, psi 4 and so on, and the wave function psi square of the wave function gives the probability of finding the particle in a position x. For the ground state, one is called ground state energy value. Let us see. If we see here, this is the potential is going to be infinite at x equal to 0 and at x equal to L. So different n values are there. So n is 1, n is 2, n is 3, n 4 and so on we will get. So for first wave function, this is a E1, E2, E3 corresponding n1, n2, n3. And if we check the wave function's value also, psi of x is a wave written as 2 by L sine of to n pi x over L. So if we check for n is equal to 1, this will become like this. Different value if we keep here in the wave function of psi x, we will get a function like this. If psi is 0, we will get the 0 point. If psi is L cancel, n pi, again we will get the 0. If our x value is L by 2, which is here, L by 2 is this point. If it is L by 2, if we keep here L by 2, L cancel, so n pi by 2, sin pi by 2, n is 1, so it is becoming pi by 2. Pi by 2 means the maximum we will get for pi by 2 values. Similarly, we can plot for different value of x. The graph will come like this. If we plot psi 2 will be like this, 2 by L sine of 2 pi x over L. So if we check the x value 0, this function will become 0. If we check x is equal to L cancel, sine of 2 pi will be 0, again it will be 0. If we check for L by 2, if we check this function psi 2 for L by 2, L cancel, so 2 pi by 2, 2 cancel, so only pi. What is the value of sin pi? Again 0. So L by 2 also we are getting 0. So we can check for x by 4 or 2x by 3. So this function will give maxima and minima, so it will coming like a sine function. Similarly, psi 4 also can be drawn here. These are the wave functions. This is psi of x, psi 1, this is for psi 2, this is for psi 3. We can also plot the probability of these wave functions, which can be plotted like this. It is v is infinite this side, 0 L. So for n is equal to 1, there is not much change. It will be the square of this is same, only the height will change. For if we make the n is equal to 2, this wave function is like this. The square of this will become only in positive. There will be no negative for the square of the wave function. So this is for psi 1 square, this is for psi 2 square. Can you plot for psi 3, psi 4? Whatever is coming negative, it will be only in positive. Try and make the psi 3, psi 4 also. We can say that the energy of the particle and the wave function of a particle which is confined to move in a infinite potential well is obtained. So we can write the En value, which is energy, and we can write the psi of x. The square of the wave function of this is giving us the probability density, means we can find the where particle is in the infinite potential well. Where is the particle if we do the square of the wave function? Also we can make the difference between classical and quantum picture. If it is classical particle, then it can have any energy. If it is quantum particle, only specific energy E1, E2, E3 is possible, not all value of En. Also it has a precise location. We can do the find the location of this, but only probability of location we can find in case of quantum particle. The particle bounces, it is bouncing with the walls. Here there is no particle. If it is particle is moving, then de Broglie has said that there is a wave always, associated wave will be there. So there will be a wave. 0 point energy is possible here. He has there is no 0 point energy in this. We cannot say this is the 0 of the energy. Here it will be always 0 energy, 0 point energy, that is the lowest point energy we can say. Thank you for this.